Hi everybody, welcome to the video for our holiday weekend, our holiday week. Today we're going to talk about solving systems of equations with 3 or more variables. Systems of equations. 3 or more variables. The techniques for this are the same as they are for 2 variables, although some of them really aren't very helpful. In 3 variables, using the graphical approach isn't very useful because we've got to figure out how to graph a 3-variable equation, and that gets really kind of hard to see. So we're not going to look at that at all. But we can use substitution and we can use elimination. So let's talk about how to do these. First of all, let's see. Substitution, good. And elimination, good. The only problem that comes up when you've got more than 2 variables is that you can start to kind of work in a circle where you start working towards a solution, but then you can start working backwards and you can end up back where you started. So being orderly and deliberate on these is more useful. So organization is key. For these problems. Okay, so let's talk about substitution first of all. Here's a blank slide, and here's the idea for substitution. Here's an example. 4x plus 7y equals 10, and I've got a blank there because we might have some z's coming up in the next equation. 8x plus 2z equals negative 14. And my third equation is 6y plus 2z equals 6. Now, the key for substitution is that you pick an equation and a variable to solve for, but after you do that, you plug it into the other 2 equations. So I'm going to pick the third equation, and I'm going to solve for z in the third equation. So when I do that, that's going to give me z equals 6 minus 6y all over 2, or z equals 3 minus 3y. Now, when I substitute in the other 2 equations. Don't substitute back into the equation you had. So I'm going to do that now. I'm going to pull my 4x down, and that one doesn't have a z in it, so that's good. 4x plus 7y equals 10. And then I'm going to sub into the other equation. 8x plus 2 times 3 minus 3y equals 10. Oh no, I'm sorry, negative 14. Let me fix that really quick so that I don't get myself confused. Negative 14. And when I clean that up, you're going to see I have a system with just 2 variables, so I can solve that. 4x plus 7y equals 10, and the other equation will be 8x minus 6y equals negative 14 minus 6 is negative 20. And so now I can solve this system. So those 2 equations became that. And so I think I'm going to use elimination at this point. So I'm going to multiply my first equation by minus 2 That'll give me a negative 8x minus 14y equals negative 20. And I have a plus 8x minus 6y equals negative 20. And that, when I add down, that will give me negative 14 plus negative 6 is negative 20y equals negative 40. So y equals 2. And then I can come back and find out what my x is from this. And once I do that, then I can find my z from up there. So I find the x. Then after I find my x and my y, I go back up and I can find z where I made my substitution. Because this is a video, I'm not going to go through all of this, okay? But if you do have questions, you can ask about that. Okay, so that's how I would use substitution here. And again, the key is once you pick your variable and your equation, you substitute in the other two equations, not in the same equation you started with. But I do want to talk about elimination in detail because this is something that you'll use quite a bit when you get into your upper level classes. And I want to talk in particular about Gaussian elimination and Gauss-Jordan elimination. So that's a fancy name. Gauss was a 19th century mathematician. He was called the Prince of Mathematics. He was kind of an interesting guy. And again, in the interest of keeping this video short, we won't talk about that really in class or here in the video, but we can talk in class if you want. But Gaussian elimination is an organized way of using elimination that we've used before. So let me remind you of the rules for this. The first rule is you can change the order of equations. Now, when we had 2 equations, that was not so important. But now that we've got 3 equations and we're going to have this process we need to follow, I'm going to definitely be using this particular rule. So can change the order of equations. We can multiply an equation by a variable. Multiply an equation by a variable. Oh, no, not a variable, by a constant. And that constant has to be non-zero. So I'll put that in parentheses. Multiplying by 0 won't help us because that would just turn everything into zeros. That wouldn't help us a bit. And then the third rule that we had before was that we can add 2 equations together, but I'm going to change this rule for Gaussian elimination. In Gaussian elimination, this thing is modified. You can add a multiple of one row to another. So that's kind of a combination of the second rule and then the adding or subtracting together. Okay. Also, when we have more than 2 variables, we're going to start to run out of letters to use. So we're going to start using subscripts. So instead of using x, y, z, and so forth, a lot of times you're going to see x1, x2, x3, and so forth. So just don't let that throw you if you see that. Okay? So here's our strategy for this. If the first variable in the top left corner has a 0 for a coefficient, I'm going to rearrange that so that I have a non-zero there, okay? Rearrange so that the x1 term is non-zero. Then I'm going to use the first equation to eliminate x1 in all of the equations below it. So I'm going to use that third rule. So I'm going to get a system that looks like this. I'm going to have my a times x1 plus b times x2 plus c times x3 plus, we'll just do 4 variables in this example. But then after I do my elimination, I'm going to have a 0 here. And in the third equation, I'm going to have a 0 in the first column. These capital letters are just constants. And in my last equation, I'll also have a 0. That's an x3 right there. And so you can see that top equation has got all 4 variables in it, but the equations below it, let me use another color here, have all got zeros. And so now I've got a new little system, okay? So after I do this, then I leave the top equation alone. I don't touch it anymore. And I repeat the process with this little system that I've circled, okay? So I would eliminate, so I get a 0 for the kx2 and the pxq, and then I would have a little system that only has 2 equations and 2 variables, and I would solve for that. And that would help me to solve for at least 1 variable, and then I do what's called back substitution to finish this. So let's go ahead and look at an example. Okay? So I've got x plus 4y minus z equals 4. I've got 2x minus 8y plus z equals minus 13. And I've got minus 2x plus 4y minus 3z equals 5. Now, when you look at this system, it looks really tempting to use the second equation to eliminate that x in the third equation. But we're going to follow the Gaussian elimination steps. We're going to do it exactly the way that they say to do it. So I'm going to use the first equation to eliminate the 2x in the second equation. And the way I'm going to do that is I'm going to take negative 2 times row 1, and I'm going to add it to row 2. And I'm also going to use the x in the first equation to eliminate the negative 2x in the third equation. And the way I'm going to do that is I'm going to take 2 times row 1 and add it to row 3. So those are my steps, and let's see what we get when we do that. My first equation stays the same. And now here's the thought process. Negative 2 times row 1 is going to be negative 2x minus 8y plus 2z equals negative 8. And so that's what I'm going to add to row 2. So when I take my negative 2x plus my 2x, that gives me the 0 that I need. And I take the negative 8 plus the negative 8. That gives me a negative 16y. I take the plus 2z plus the other z, and that gives me a 3z. And I take the negative 8 plus the negative 13, and that's a negative 21. See what I'm doing there? All right, let's look at how when I take 2 times row 1 plus row 3. 2 times row 1 is going to be 2x plus 8y plus 2z equals 8. And now I'm going to add my 2x and my minus 2x give me a 0. My 8y plus my 4y give me a 12y. My 2z and my minus 3z give me a minus z. Oh, I've got a mistake there. Let me catch it. That's a negative 2z. So my negative 2z plus the negative 3z gives me a negative 5z. And then the 8 plus the 5 gives me a 13. And you can see we've eliminated those x's. So now I solve this system. I leave the first equation alone. So I'll solve that little tiny system now. So let me go ahead and cut that out, and I'll put it on the next slide so that I don't have to rewrite it. And I'll get rid of that, and I'll get rid of these bright ideas that PowerPoint has for us, and I'll move that up in the corner. So now I think I'm going to multiply row 2 by a 3, and I'll multiply row 3 by a 4 so that I can get the same numbers in front of each one. Remember, one of the rules is that I can take a multiple of one row times it plus another row, but I can also multiply a row by a constant, non-zero constant. So that'll give me my 0 and a minus 48y plus 9z equals negative 63. And my 4 times row 3 gives me a 0 plus 48y minus 20z equals 52. And now I'm going to take row 2 plus row 3, and that'll go into the third row for my next step. So my first row stays the same. My second row stays the same now from what it is now that it's been transformed. And now I'll add minus 48 plus 48 is 0. 9 minus 20 is, let's see, 9 minus 20 is negative 11. And negative 63 plus 52 is also 11, isn't it? Oops, that's an equals. Yeah. So now I can finally solve for z. Row 3 times 1/11. Technically, that's what's going on when I divide by negative 11, and I'm dividing by a negative 11. So row 3 times negative 1/11. That gives me z equals minus 1. And now I can come back and find my y. Negative 48y plus 9 times negative 1 equals 63. And that's going to give me y equals 63 plus 9 all over 48, which is 72 over 48. And let's see, 12s go into that, so that's 6/4, so that's 3/2. And now I can plug both of those into the top equation, which I'll do up here. X plus 4 times my 3/2 plus negative 1 equals 4. So x plus 4 over 2 is 2, plus 6 plus 1 equals 4. So x will be 3 minus 6, which is minus 3. And then I have my solution. and so forth. So that's the process. We work straight down. Okay. Let's do another example. This one is a little bit more streamlined. Okay. Instead of writing all those x's and y's and z's, I'm going to make what's called the coefficient matrix for this. So I'm just going to write the coefficients. Those variables are really just taking up space, right, and time. So here's my example, and that's x plus y plus z equals 85 minus 2x plus 5y equals 92, and x minus z equals minus 9. And what I'm going to write is I'm just going to take my coefficients. So I'm going to write a 1, a 1, a 1. Then I'm going to put a dotted line, and I'm going to put my right-hand side over there, my 85. My minus 2, my 5, I'm going to put a 0 to keep a placeholder, and I'm going to put a 92. My 1, a 0 for a placeholder, and a minus 1, and I'm going to put a 91 there, or minus 9 there. So I'm just taking the coefficients on the right-hand side. This is called the coefficient matrix, or actually not the whole thing is the coefficient matrix. I take it back. This side here is called the coefficient matrix, and the whole thing is called the augmented matrix for the system. The whole matrix is called the augmented. To augment something is to make it bigger, right? So I've taken the coefficient matrix and I've made it bigger by putting the right-hand sides on it. So let's talk about how we would solve this. I'm going to use the same process before. Okay, so let me go ahead and write my matrix. 1, 1, 1, 85, negative 2, 5, 0, 92, 1, 0, negative 1, and negative 9. And I can see that if I take 2 times row 1 and add it to row 2, that I can eliminate that minus 2. Remember what I'm doing, I'm going for these two. I'm trying to get rid of everything in the first column below the first row. And if I take minus 1 times row 1 and add it to row 3, that will eliminate the 1 right there. So let's go ahead and do that. Okay, so my first one added times 2 is a 2. Added to my minus 2 is a 0. Oh, let me write my first row first. Now let's do this. My first one times 2 added to minus 2 gives me a 0. This one times 2 gives me a 2. Added to 5 gives me a 7. This one times 2 added to 0 gives me a 2. And this one is 170 added to 92 gives me a 262. Now I'm going to take minus 1 row 1 and add it to row 3. So my top one times minus 1 gives me a minus 1. Added to that one gives me a 0. This one times minus 1 is minus 1. Added to 0 gives me a minus 1. This one times minus 1 plus that other minus 1 gives me a minus 2. And 85 times minus 1 is minus 85. Added to minus 9 is minus 94. So I've accomplished that so far, and now I have this to work with. I am going to swap rows. So I'm going to put row 3 in the place of row 2 and row 2 in the place of row 3. Notice the thing that I'm writing it next to the row that gets changed. So row 2 becomes row 3, so that's why I write the row 3 next to row 2. And that's why I write the row 2 next to row 3. It's always useful to have a 1 or a -1 in that top corner. That's called the pivot position, by the way, in upper level courses. So it's nice to have a 1 or a -1 for the pivot. So I'm putting my row 3 in my row 2 place, never talking right at the same time. Let me fix that. There's my -1. That -2 goes there, that 94 goes there. 0, 7, 2, and 262. And now I'm going to take 7 times my row 2 and add it to my row 3. The top row stays the same. The second row stays the same. In the third row, 7 times 0 added to 0 is still 0. 7 times -1 added to 7 is a 0. 7 times -2 is -14. Added to 2 gives me a -12. 7 times -94, oh my gosh, added to 262. Let me look that up. That's -396 when I do that. And now I've got what I need. Notice I get this kind of little stair step when I do this. This is called row echelon form when I get these stair steps. Okay, and that corresponds to this equation, x plus y plus c equals 85, minus y minus 2z equals -94, and minus 12z equals -396. So that equation corresponds to that system. And now I can go ahead and solve it. Let me put this on the next slide so we've got some room. And again, I'll make it a little smaller so we've got some space. But I can see here z is equal to -396 over 12. And that works out to be 33. Let me write it down there. And now I can take my 33, I can plug it in up here. This is going to give me the equation y equals 94 minus 2z. Okay, and so when I plug my 33 in, that gives me 94 minus 66, and that works out to be a 28, if I think right. 6 plus 8 is 14. 6 plus 2 is 8. Carry the 1. Yep. Okay. And now I can put both my z and my y in the first equation. This is going to give me x equals 85 minus y minus c. And so x is going to be 85 minus 28 minus 33, which works out to be 24. So now I have my solution. Okay. Now, just like before, when we had two equations and two unknowns, we could possibly have one single solution. We could have an infinite number of solutions, or we could have no solutions. And the same thing can happen here when I have a system of linear equations that has many variables. So how do you tell what you get? And the answer comes down to what happens in the bottom row. So these are our possibilities for solutions. And if you work all the way down to the bottom, you've got all your zeros, and you have a non-zero here for your very last variable, and you have a non-zero here on your right-hand side. This system has a single solution. However, you could work down so you get a whole bunch of zeros, and you get a zero for all of your variables, and you get a non-zero on the right-hand side. This system has no solutions. And the reason it has no solutions is because this bottom row becomes 0x plus 0y plus 0z plus da-da-da-da-da-da plus 0w equals, like, say 5. Well, this right-hand side is 0, and the left-hand side is 0, and the right-hand side is 5, and that can't work. So that's why that has no solutions. So no solutions in that case. Okay? And there's one more thing that could happen, is that your bottom row could have zeros on all the left-hand side and a 0 on the right-hand side. And this one has infinitely many solutions. Now, we're going to start using parameters to write the solutions. And I'm going to show you what that means in a second, as soon as I write this out. We'll look at an example. Suppose I have x minus y minus c equals 1, minus x plus 2y minus 3z equals minus 4, 5x minus 2y minus 17z equals minus 4. So that becomes this matrix. When I look at the coefficients, the first equation has a 1, a minus 1, and a minus 1 for coefficients, and it has a 1 for the right-hand side. It has a minus 1, 2, and minus 3 for coefficients, and a minus 4 on the right-hand side, a 5, a minus 2, a minus 17 on the left-hand side, and a minus 4 on the right-hand side. And after I solve the system, I won't go through the steps. I'm going to get this. I get a 1, minus 1, minus 1, and a 1. I get a 0, a 1, a minus 4, and a minus 3. And I get a 0, 0, 0, and 0. That's just what happens after you do it. So now I know from this bottom row that the system has infinitely many solutions. But now we're going to go farther than we would before. We're actually going to put our solutions in terms of a parameter. Now, MyMathLab will tell you what variable to use, and it usually says to use z, but you could use y as well. Okay, so we're going to use z for the parameter. So here's what I'm going to do. In my second equation, actually let me write my equations out. X minus y minus z equals 1. Y minus 4z equals minus 3. Okay. And so I'm going to take my second equation and I'm going to solve it for y. No, I take it back. I'm going to solve it for z. Nope, I was right the first time. I'm not thinking straight. I'm going to solve it for y. So I'm going to solve for the other variable that's not the parameter. The non-parameter. So that's going to give me y equals minus 3 plus 4z. And I'm going to plug that in to my top equation. So let me do this on the next slide. I had x minus y minus, let me look at my notes here, z equals 1. I have y minus 4z equals minus 3, but that turns into y equals minus 3 plus 4z. And now I plug that into the top, and that's going to give me x minus 3 plus 4z minus another z equals 1. And when I clean that up, that's going to be x plus 3 minus 5z equals 1. And when I solve that for x, that's going to give me x equals 1 minus 3 is minus 2 plus 5z. So my solution is going to look like this. X equals minus 2 plus 5z. Notice there's a z in my solution. Y equals minus 3 plus 4z. And z equals c. This is my solution to the system. Now here's what this means. This means that no matter what number, you pick your favorite number and you plug it in for z, and that will be a solution to the system. Okay? So any real number. You can pick 0, you can pick 10, you can pick pi, you can pick, 42, any number that you want. So you pick it, you plug it in for z, and that will be one of the solutions to the system. And get rid of that. So it's one of the infinitely many solutions to the system. And that means that when I write this in terms of z, what I've got with the box is that this is a shorthand way to list all of the solutions. Okay, So that's how we're going to handle more than one variable when we work with this. Okay, we also need to work with systems of inequalities, but I think that this is a long enough video right now. I'm going to make another video, or we can talk about that. Actually, we have time when we come back next week on Tuesday. So we'll be talking about that when we come back from break. In the meantime, I hope you're having a happy holiday, and I'll see you next week. Thank you. Bye-bye.